Hi, my name is Angus Smith, and I'm a master's student at the University of Northern British Columbia. Today, I will be presenting for you on some preliminary results from my master's thesis on the relationship between barren ground caribou and winter roads in the Northwest Territories. Before I get going, I'd like to thank my supervisor, Dr. Chris Johnson, for their support throughout this process. In this presentation, I'll first give you an introduction to the issues around caribou, then a brief overview of the methods that I'm using in my project, an overview of the specific crossing analysis that I'm doing, and some preliminary results from it. So caribou around their circumpolar distribution are in decline. As highlighted by this map on the right here from Vors and Boyce 2009, you can see the ranges in red are declining and the ranges in green are increasing. Now this paper was done just over 10 years ago, but the picture it paints is still broadly speaking true. Declines of caribou could be very impactful to the ecosystems that they are in, and also the people that depend on them, both for sustenance, hunting, and for cultural continuity. The causes of the declines are complex and often region-specific, including both environmental changes, mostly brought on by climate change, but also due to the impact of anthropogenic disturbance, that is, disturbance by humans. Barren ground caribou are located throughout northern Canada. This map here on the right shows ranges of herds throughout northern Canada, including the Northwest Territories. I'm doing work looking at just bring up a laser pointer for you, the Bluenose East, Bathurst, and Beverly and Ohio herds, which overlap with portions of the Northwest Territories. Here's Great Slave Lake here. I'm doing work just north of Great Slave Lake, looking at the relationship between barren ground caribou and the diamond mines located there, along with their supporting winter roads. It's my hope that we can help wildlife managers understand how caribou and these disturbances relate. So work has been done previously looking at this region and these industrial features. So if we look at this map here, we're zoomed in a little bit. We're just north of Great Slave Lake, Yellowknife in the bottom left, and in the upper right we have Ekati, Diavik, and Gachoku, diamond mines currently active in the Northwest Territories. The black line is the winter road that supports these features. So here we have the main spur going from Yellowknife to Diavik and Ekati, the Jaya side spur right here going to Gachoku, and then two less used spurs going, this one to the Lupin property and this one to the Tundra property. So previous work on these features has found something called the zone of influence. That is, they found an area around these features of about 14 kilometers, shown on the map here now, where caribou are less present compared to elsewhere on the landscape. So a zone of influence, it's kind of a nebulous term, so I'll walk you through that. So it's specifically defined as the geographic area adjacent to a disturbance across which animals change their behavior, habitat selection, and distribution. It's the description provided by Boulanger et al. In 2012. Boulanger and other authors before them found this distributional effect associated with industrial features for barren ground caribou in the Northwest Territories. But how do you manage for a feature, this indirect kind of understanding of how a disturbance feature influences an animal? It's difficult to understand how to mitigate for that. So by applying a cumulative effects lens, here's a description of cumulative effects, which basically is just saying that these broad scale phenomena are the result of the cumulative effects of fine scale relationships and interactions. So I'm hoping to add to this zone of influence work by completing a fine scale analysis of the relationship between barren ground caribou and winter roads specifically. So this builds on previous zone of influence work, but excitingly for me, steps into a new area where I can look at the relationship between winter roads and barren ground caribou, which has not been explored very much in the Northwest Territories. So for this project, I have three methods that I'm applying. First, assessing caribou behavior, going out, watching caribou, collecting behavioral observations. Going out, while I am going out and collecting those observations, also collecting fecal pellets, so I can assess physiological stress in these animals. That would be cortisol and corticosterone metabolites from those fecal pellets. And I'm doing both of these both near and far from these industrial features to try and assess the effect of them on these metrics. But the analysis I'm going to be talking about today is a crossing analysis where I'm using telemetry collar data to assess the relationship between features associated with the road and whether or not they cross that road. So I will step into that now. But first, give a brief overview of the state of my project. So I've completed the fieldwork, which happened over 2 winter field seasons, both in 2019 and 2020. And I've completed a preliminary analysis of the winter road crossing. Outstanding, I still need to finish the winter road crossing analysis, as well as analyses of both the behavioral data and the stress hormone data. The core question for the crossing analysis is what factors influence crossing of the winter road by barren ground caribou? And the specific hypothesis that I'm looking at in my preliminary analysis is whether industrial traffic influences the crossing likelihood of caribou. So I'm looking at both level of traffic and presence or absence of traffic on the road. But we'll get into that. So I'm using logistic regression to look at this. My ones will be the real crossing events contrasted with the zeros, which are simulated crossing events. So let's walk through briefly what those are. So my real crossing events are based on inferred caribou movements from telemetry collar data. My simulated crossing events, which you can think of as a measure of crossing events the caribou could have done, or available crossing events, are based on caribou movements adjacent to the road from the telemetry collar data. Now, due to the type of logistic regression that I'm using, there are more simulated crossing events than real crossing events, and you'll see that throughout the figures that follow, just so you're aware. Before we get into what the crossing data looks like, what the traffic data looks like, I think we need to stop briefly and ask, what is a road? So I'm not being silly here. So we're talking about a winter road. A winter road is not a permanent feature on the landscape. The winter road is constructed every year in January, persists throughout the active season, throughout February and March, a little bit into April, and then persists on the landscape after the traffic has left it. So here's some satellite imagery to just reinforce my point. This is on the Lupin Spur on Pellet Lake, north of Diavik and Ekati, about 2 weeks prior to the first recorded traffic. And if you look there, it's a little faint in this image, you can see the presence of a road on the landscape. And then if we look at this image, just shy of a month after the last recorded traffic on this spur, you can still see a feature present on the landscape. So to get the caribou crossings, I took satellite telemetry collar data. The GNWT has been running a program since 1996. However, I was only interested in more recent data. The light gray here on the map is the totality of the data through January and April, January to April from 1996, but I'm only interested in more recent data and the high quality so-called geofence data, which is very high frequency, so I could get a good idea of actual crossing times and locations. From that, I was able to generate a set of crossings here on the map and a set of simulated crossings. And you can see that they largely mirror each other in space. So if we just look at the crossings throughout time, just to get an idea of what our data looks like, here are the actual crossings. So day of year is on the x-axis of this histogram. Day of year 1 would be January 1st, and day of year 125 would be shortly after the end of April. So we're looking at the set of crossings here and the set of simulated crossings. Now I'm not going to read into this too much. I'm going to move right along. So what are the traffic data? The traffic data I derived from a set of dispatch records for the winter road traffic, which gives the date and time each vehicle left a location and the date and time that it arrived at a location. And using that, I was able to generate simulated tracks for each of the vehicles, and from that determine the level of traffic at any given location and time for my crossing events. Now for the traffic data here, we have 3 histograms showing traffic levels in 2018, 2019, and 2020. The x-axis, we have date. So the winter road typically opens around the beginning of February and typically closes right at the start of April. what I'd like to draw your attention to here is how the traffic level increases quickly every season, maintains a fairly high level throughout the season, and then decreases fairly quickly towards the end of the season. So we have the crossing data, we have an idea what that looks like, and we have the traffic data, and we have some idea of what that looks like. How do we relate the two? How do we assign a traffic level to our simulated crossing events and to our real crossing events? Well, I created two metrics of traffic level, a narrow time window and a broad time window. So the traffic index is my narrow time window, and I'll just provide an example of it on the other one here. In this map, we're going to draw an example crossing that happened around the Lupin Spur, or sorry, the Tundra Property Spur. And here on the x-axis, we have the date. The blue line is the date of the crossing. And here was the level of traffic, the number of trucks passing by the location of that crossing around that time. So the traffic index, very narrow window, only looks 8 hours forward in time and 4 hours back in time. And there we go, we can see it on the image now. And it records the number of vehicles, the count of vehicles present in that window. So that's a very kind of fine temporal window looking at the traffic. So let's do a broader window as well to get an idea of whether or not this crossing happened on a currently used road, an active road, if you will. So that's a much broader time window that I applied for my active index. And that goes 3 days before the crossing and 4 hours after the crossing. And it's just recording whether or not there was traffic, not the count of traffic. So if we look at our data, we've got a box plot here of the traffic index for both simulated and real crossings. And you can see already that there seems to be quite a split between the two of them. But before we read into this too much, how about we add a time component? So here's a histogram of the simulated crossings and another histogram of the real crossings on the right, simulated on the left. Day of year is on the x-axis. And the third piece of information that we've added here is the level of traffic, so the bin traffic index. And you can see that as the darker gray sections of the histogram. It seems that there is a pretty clear relationship going on here, and this is for the traffic index. But this also, if we look at the active index, the active road, whether or not there was any vehicle within about 3 days prior to the crossing, we see largely the same relationship, which is crossings during the winter road season, and I'll just bring in a laser pointer for you, seem to be largely associated with some presence of traffic, and simulated crossings during the winter road season are also associated with some level of traffic. And if we pull in the open dates and close dates for the winter road season outlined here in the green lines and the red lines, that seems to help confirm that story. But here we're just looking at figures and telling stories, so it's important to do a proper statistical analysis. So I'll go over that briefly. So for my statistical analysis, I use logistic regression to contrast the real and the simulated crossing events. The covariates are aspects that we've already spoken about. So the traffic index is the count of vehicles in a narrow window around the crossing. The active road covariate is just a true or false flag associated with any traffic in a broader time window around the crossing, so 3 days before to 4 hours after the crossing. The open road covariate is just asking whether or not this crossing happened during the open season of the winter road, so between the open date and the close date for that year. And of course, I'm attempting to correct for the day of year and year in my modeling. So in this preliminary analysis, these are the 4 models that I proposed. One just associated with the traffic index, model 1, saying that the count of vehicles in that narrow window would explain whether or not a crossing happened. Model 2 says that caribou are not only responsive to the traffic index, but also whether or not the road overall has been active. So both the traffic index and the active road flag. Model 3 is just saying that caribou respond to whether or not the road is active. And model 4 is the coarsest by far, just saying caribou are more likely to cross when the road is closed as opposed to open. Right, and let's see what happens. So I used Keki's information criterion to select the most parsimonious model. So what that means is the model that explains the greatest amount of variation while using the fewest parameters to do so. In this case, that's selected model 2. So it's saying that my most parsimonious model, my simplest model that explains the most variation, includes regression covariates for both traffic index and whether or not the road was active. So what does that tell us about Caribou? First, let's take a look at some regression covariates. So if we look here, there's a lot going on. I want to draw your attention to this box in the upper right, which outlines the coefficient values for model 2, which was found to be our best model. So we have both the active road flag here, if the road was active, and the traffic index. And in both of them, it's saying that there is a negative relationship, and the 95% confidence intervals around those coefficient values do not overlap 0. Now, remember that both of these things are not standardized, so the absolute value of them is less important than the direction and whether or not the confidence intervals overlap 0. So what does this mean for Caribou? Well, it means that there is quite likely a negative relationship between crossing likelihood and the presence of traffic on the winter road. Keep in mind that these results are preliminary, however, and that my future crossing models will be amended to include other environmental and disturbance factors that could influence crossing activities such as hunter activity, terrain type, or weather. And these more rigorous findings will be incorporated into the analyses of the behavioral data and the stress hormone data to provide a more complete picture of the relationship between barren ground caribou and winter roads. I'd like to thank you very much for listening to my whole presentation. This is a strange format we have with pre-recorded presentations, and I hope you enjoyed it. Before I go, I'd like to thank the funders and supporters of this project, and of course my field staff. You know who you are. Put in good long hours on this project. Without them and these funders and supporters who provided funding, in-kind support, and staff hours, this project wouldn't have been possible. Thank you very much.